Hello everyone, my name is Amit Arora. I'm software engineering manager with more than 20 plus years of experience. Today, I have pleasure to talk about how we can engineer a real-time translation platform system that allow truly seamless communication across languages, and why engineering behind them is just as important as the AI model themselves. Interconnected world where conversation happen across borders every second. Yet language is still one of the biggest barrier to collaboration, learning, and even safety. My goal is to show how scalable AI infrastructure can bridge that gap and why translation is moving from being a convenience to becoming a mission critical infrastructure for our digital economy. Okay, so let's first set the stage. So, real time translation platform are not just research experiment anymore. They're becoming essential part of how people communicate globally. The expectations are very high. So we are talking about processing millions of conversation daily. We have to support more than 40 plus languages. We have to hit translation accuracy above 85%. And all of this in a very small response time of under 200 milliseconds. So traditional translation tools simply cannot meet the scale and the latency requirement we are talking about, which is why the next frontier lies at the intersection of the advanced AI models and robust system engineering. To make sure that we are able to build this platform must address four interdependent imperatives. The first is performance. The latency has to be very low and with a very high throughput. Users shouldn't feel any lag in such a system. The second one is the scalability. We have to support millions of concurrent sessions across the globe. And the system and this platform has to be very reliable. It has to be available even during failures or heavy loads. And finally, the accuracy, and it has to preserve the context, making sure that meaning is not lost. People might use idioms, they might use slang, they switch languages during mid sentences or speak in mix of languages. To build this platform, the challenge is not to optimize just one of these things. All four of these should work together really well to make sure that platform is production ready and is usable. So fun part, let's talk about building this one. So first let's talk about the architecture. So the real-time translation systems are typically organized as the modular microservice. Each one does one thing but does it really well. So if we talk about the workflow, so speech first goes through your automatic speech recognition to become text. Then we do pre-processing, which normalize the text. And after that, we use neural machine translation, convert instead to the target language. And then post-processing cleans up. And finally, we will have text-to-speech that generates natural audio output. So we will keep each of these steps separate and so that we can independently scale, we can upgrade them, we can monitor these components without breaking the entire pipe. So the modularity is the backbone of the performance and throughput optimization. So now coming to the deployment, how are we going to do that? So models are packaged into containers and we will orchestrate them by platforms like Kubernetes. This will give us version control. We can run domain specific models side by side with a general purpose one. It also enables safe deployments. We can use blue green strategies. We can run new and old models in parallel and roll back instantly if something goes wrong. We can employ canary releases. So we gradually roll out updates to small percent of the users, see how it does performance wise. And then if everything is well, we scale it to everyone. So this will ensure we never disrupt mission critical use cases. So this is very important that centralized cloud processing is not enough. Imagine a user in India or Africa need sub 200 millisecond latency. And if you're sending everything back to US data center, we'll never meet our requirements. So that's where edge computing comes in. We will deploy all these modular components, ASR, NMT, TTS components closer to the users. We can reduce the latency by 40%. We can cut our upstream bandwidth usage by almost 60%. And most importantly, we keep that sensitive data within the local jurisdiction. which helps with the regulatory compliance each country has. So, if you think about this, edge computing isn't optional or nice to have for this system, it's a fundamental part of the system. So, next is data and hardware. On the data side, we use streaming pipeline like Kafka and Flink for low latency ingestions and batch pipelines for retraining and analytics. So on hardware side, the GPUs are the bottlenecks. So we have to make sure that we do efficient GPU scheduling so the multiple models don't collide during peak loads. And we use caching aggressively to for the common phrases, domain specific terms, user dictionary to speed up translation while improving accuracy. This combination keeps the system both fast and the cost efficient. Now, like none of this will matter if you don't know what's happening in your production system. So telemetry is a nervous system is the most important part of your platform. We have to track metrics like latency, we should track throughput, accuracy, error rates. We use distributed tracing to pinpoint what are the bottlenecks across microservices. And we feed this user correction back into the system to improve accuracy over time. We have for fault tolerance, we design for redundancy across regions. We allow graceful degradation by falling back to simpler models when GPUs are scarce. We build self-healing, automated restart, load balancing when the service fails. So resiliency has to be engineered, designed, and from the start of the platform we have to incorporate those, and it doesn't have to, it's not accidental, so it has to be very intentional. It has to be in the start of the system, and it has to engineer it from in the whole platform. So another fun thing, let's look at some of the real world impact of this real-time translation platforms. So in healthcare, if there's a miscommunication between provider and patient, it can be a matter of life and a death. So a hospital system deployed domain-specific medical translation models at the edge nodes inside hospitals. And as far as the impact is concerned, a 35% reduction in critical medical communication errors that directly improve patient safety and treatment outcomes. This is a clear example where translation literally saves life. Now, we all have seen this one as education. In online classroom, we have diverse student population. They often struggle with the language barriers. So by integrating real-time captioning and translation into the video conferencing platforms, students were able to fully participate regardless of the native language. The results were more inclusive, accessible learning environment, and there's no student left behind because of the language barriers. So finally, coming to the enterprise collaboration. So global team lose efficiency due to language gaps. You're having meeting across international teams. By embedding real-time translation directly into the platforms like Teams and Slack, your organization can see more than 40 plus improvements in collaboration effectiveness. This can translate to faster decisions, fewer misunderstanding that happens, and better outcomes for international projects. So from these use cases and from the previous slides and previous experiences, so these are the best practices that emerge. First is like you design for modularity. You always do one thing and you do one thing really well. You're able to independently scale, independently update that components like separate ASR, NMT, TTS we talked about. Use hybrid cloud strategy as well as edge architecture, which is a must-have for real-time translation system. You automate your deployments using CI/CD. You have to prioritize, and that's a must-have, observability with the full tracing and feedback loops. You have to plan redundancy from the start. Assume this will happen. Plan for it and make sure that it's implemented. Like GPU is scarce, so you have to optimize for GPU usage. You have to aggressively use caching. And I think one of the most important thing is you have to support contextual translations because the meaning matters more than the literal word substitutions. So at the high level, these are the principles that make translation platform reliable at scale. Okay, future direction. Looking ahead, the possibilities are exciting. Imagine we can build personalized translation models which are tuned to individual users and organizations. We can create those context aware NMTs that uses conversation history to improve the fidelity. We can have that federated learning at the edge that allow training without sending the sensitive data which you don't want to send to the cloud. We can have multi-modal translation. We can combining speech, text, even visual will unlock such a richer understanding. And we must prioritize sustainability, optimizing GPU workloads for lower energy consumptions. So the future of translation is intelligent, adaptive, and green. So let's bring it all together. So engineering real-time translation platform is both an AI challenge and a system engineering challenge. It requires low latency pipelines, fault tolerant architecture, efficient resource management, robust observability. When done right, these platforms saves life in healthcare, democratize educations, and accelerate global collaboration. So overall, translation is not just convenience anymore. It's infrastructure for digital economy. Thank you so much.